I'm Anil Kumar, and in this video we'll try to understand the cast rule itself. Now, as you know, the cast rule tells us the sign of a trigonometric ratio in different quadrants. That is to say that if I have a coordinate plane which could be divided into four parts, then we have seen with the help of cast rule we can find sign of a trigonometric ratio. We say that in quadrant 4 cosine is positive, in quadrant 1 all are positive, in quadrant 2 only sine is positive, and in quadrant 3 only tan is positive. Now the question is why? The question is why? This is what we are going to answer in this particular video. So what we will do is we'll just consider a set of points in these quadrants, okay, and see why is that so. Correct? So if I have a point, let us say in quadrant 1, then you can see that the x value is positive, right? And y value is also positive. So we'll have a value which will be kind of a and b, where a is the x value and b is the y value, right? In general, any point on this kind of a circle will be, let us say, let me write any other point, right? Let me write this point as x and y, correct? So that will be any point on the circle, right? So if I kind of drop a perpendicular from here like this and join it with the center, I get a right triangle, right? In this right triangle, always you'll find that along the x-axis we have the x value, along the y-axis we have the y value, right? And the angle we are talking about is the principal angle theta, right? So if you analyze, then what is sine theta equals to? Sine theta is, let us say this circle has radius of r, right? So sine theta will be opposite over r, which is y over r. Cosine theta will be adjacent value x over r. And tan theta will be ratio of opposite side over adjacent side, that is y over x, correct? So that is how sine theta, cosine theta and tan theta will be. The value of r is what? R is actually square root of x square plus y square, which for us is always positive. Do you see that? R is always positive. Square root of x square plus y square, always positive. But x and y values can be negative depending on in which quadrant you are. That is the key to understand, right? So depending on quadrant, x and y values can become positive or negative, correct? So that plays a huge role in defining the sign for all these, right? So if I have all positive, as is the case in the quadrant 1, so in quadrant 1 we know x value and y value both are positive, correct? So, and we know r is always positive. R is always positive. So in quadrant 1, since both are positive, r is also positive, all these ratios are positive, right? So let me write with the red ink, all are positive in quadrant 1. So that is not a problem at all to understand, right? Now, as we move to quadrant 2, what happens? In quadrant 2, when we are at that time, let us say here, y is positive, but x is negative. So again, if you're looking into the value x and y, what you notice here is that the x values are negative, but y values are positive. So every ratio which depends on only x will become negative, right? Now, let us see y over r. Y is positive, r is positive, so this one is positive. However, in cosine theta, x becomes negative. So, negative over positive will give us negative. For tan theta, y is positive, right? X is negative. So, it is positive divided by negative, so you get a negative answer. So, in this quadrant, therefore, only sine is positive. I hope you get the point, right? So now we will skip something and we'll go to the lower half of this quadrants. So in lower half, we have quadrant number 3 and 4, right? So let us say quadrant 3 and quadrant 4. When you are in quadrant 3, that means a point here, x is negative, y is also negative. So here, x and y both are negative, right? So let me write like this, negative, negative. Now what happens to our ratios? Negative divided by positive gives me negative, right? Negative divided by positive gives me negative. But here, negative divided by negative gives me positive. Therefore, tan is positive, others are negative. You get the point, right? In quadrant 4, what happens? In quadrant 4, again, let's look into x and y positions. Okay. X is positive now, but y is negative. So x is positive, y is negative. You get the idea. So if you again apply this ratio, y is negative, r is positive. So this becomes negative. Sine is negative. For cosine, x over r, x is positive. Therefore, cosine is positive. For tan, y over x, y is negative, x is positive. Negative divided by positive will be negative. Correct? Therefore, you get negative for tan. So that is why you will find that all are positive in quadrant 1, sine in 2, tan in 3, and cosine in 4. So that is how it is, and I hope it makes sense to you. So in general, if I say that cos of theta is positive, what do I mean? I mean that theta could be in quadrant 1 or in 4. Do you get the point, right? If I say that sine theta is negative, then what do I mean? Negative sine theta means we are in quadrant 3 or in quadrant 4, right? That means 3 or 4 sine is negative. Do you get the idea? So that is how we have to see the ratios. An important thing here is that if I say that cotangent is theta is positive, it means what? It means tan theta is positive, right? It means tan theta is positive, and that means what? It means we're talking about quadrant 1 or quadrant 3. You get the idea. So it is a very helpful feature, and it helps us to solve a lot of trigonometric equations just by the knowledge of the sign of a trigonometric ratio. I hope you can appreciate it, and we'll have a number of questions which will refer to the cast rule. In fact, all the questions which we'll be solving will actually refer to cast rule if we are looking for angles more than 90 degrees. I hope that makes sense. Thank you and all the best.